So the next few slides that I want to discuss a few other phenomena that has also been widely studied. One is supervised classification. The idea is when you have, in reality, in certain domains, there's lots of labeled data. But in majority of the other places, labeled data are scarce. So semi-supervised classification try to use labeled and unlabeled, especially try to make use of the unlabeled data to improve system performance. One method, self-training, the idea is very simple. I have one classifier, I train it on our labeled data. And then I use this trained classifier on the unlabeled data. And I will take my output with the strongest confidence, use those as my label data. So I use my trained model to predict, and from the prediction, select the ones that the system was most sure about to add those to my label data. And you repeat this process to grow the label data. I think we can all see this method is very biased because it also could reinforce errors because you're using the same data, the errors will never be known to, even you see the most confident examples being selected, the most confident ones may not be correct. And you enforce this classifier's model, so the model ends up only can be used for this type of positive examples. Other positive examples has never been discovered by this classifier, therefore never been used, never been added to its training pool. So therefore people has developed the second method called co-training, where you have two or more classifiers. In most cases, there's two classifiers to teach each other. The idea is if these two classifiers make different kinds of mistakes, then we can actually add high confident predictions from one classifier to the training examples of the other classifier. So they can mutually provide, they provide training examples to each other. Because their mistakes are independent or they make different mistakes, we can hope that the new training examples added are actually going to represent the true feature space better, obviously better than the self-training method. This method has this since we want the method to actually produce very different errors, this in practice is very hard to do. And in one scenario that this kind of requirements can be met is when you have a learning problem that actually can be treated from different perspectives. For example, when you classify web pages, high quality or low quality pages, you can, based on the web page's content, what text, what keywords being used, but you could also classify them as high or low quality based on how many links that they receive from other pages. So this, the same problem provides you two independent views, and you can train two classifiers to, in this co-training scheme to create training examples for each other. So other problems, when you actually have two sets, for one problem have two sets of different features, and either set of features is sufficient for you to train a good classifier. not perfect classifier, but a good classifier. And then you can, in those scenarios, you could also use this co-training method. Active learning. Again, when training, the class labels are expensive to obtain. The idea is, let's not just randomly ask a human to create training examples. Let's have the machine to tell us what training examples the machine need. So now the method, this method sounds great, but the question is, how does the machine know which training examples should be needed? One easy way is to use multiple classifiers. If multiple classifiers classified this example with different class labels, then this would be an uncertain observation or example that need to be human labored. There's other researches in this area, but in general, this is still an open question, how to best choose the data tables to be queried.